Okay. Well, hello and welcome to Hello Qt. The purpose of this talk is to give you a fairly broad overview of Qt. I've been working with Qt since 2000, and I co-wrote both the standard textbooks on Qt. So I've got a fairly broad knowledge of what's in the Qt library. Now, clearly, I can't summarize 600,000, 700,000 lines of code, even in an hour's talk. So what I'm going to do is I'll give some introductory material, and then I'll focus on some of the key technologies that Qt offers and that I think are of wide interest. If at the end I haven't covered a technology you're interested in, then ask. I'll also mention why use Qt, but I'm not going to mention the enjoyment. I think you'll find that if you ask Qt programmers if they actually enjoy using the tool, they will say yes. It is actually a pleasure to program in Qt, and especially if you've come from either raw C++, or even if you've come from Java and used AWT or something like that. The emphasis is not primarily technical, although I will give some of the background to some of the technical issues, and I will give a little bit of code just to give you a feel for it. But mostly we'll cover what Qt offers. Some things I just won't have time to cover, and I'll list some of those at the end so that you've got a feel for what else is available. Okay. I suppose when we're asked what is Qt, well, today it's an application development framework. It began more as a GUI toolkit, but it's grown much broader. It's very well documented. It's stable. It was object-oriented from the beginning. Object orientation was not bolted on later. They started that way. So they've always had a good, clean architecture from the beginning. And you can take Qt, integrate it with your environment if that's how you work, and you can be productive very quickly. And you don't often have to get additional libraries than Qt because it's got pretty well everything you want right in the box. In addition to being a C++ class library offering you all the classes that will, well, some of the classes which we'll cover, there are also a set of tools that help you build applications cross-platform, a design tool, a Qt Designer that I'll mention more, and also tools to help with internationalization. Traditionally, people have viewed Qt as a toolkit for building GUI applications, and that is certainly true today, and that's its greatest strength. However, with Qt 4, the library was broken down into a few components. So it is perfectly possible now to say, I don't need GUI programming. I'm writing a server or I'm writing a console application, so I just won't use that chunk. I won't have that library. I'll just use the core library that gives me the data structures and other facilities of Qt for making non-GUI applications. So you can use it for both now in a very nice way. I think if we take as a given that Qt is good quality and a pleasure to use, and it'll come across a bit in the talk, but until you actually start programming it, you don't really get a feel for that. So one of its main strengths, if we take that as a given, is that it is a single API. So it means if you're programming Windows 98 and Windows 2000 and XP, you don't have to care about the differences between those different Windows versions. Of course, the same API will work for the Mac and for Linux too. But I think one of the things that TROLLTECH perhaps don't make as much emphasis of as they could is that there are quite significant differences between Windows versions, and they're all abstracted away by Qt. You just program to the Qt API and you get what you expect. And if particular Windows platforms don't have certain facilities that later ones do, you'll often find that Qt implements those for those older platforms so that you use the same API and can do the same thing no matter what version, and don't have to worry about it. People often say C++ is a much harder language to learn and use than, for example, Java, and I think that's true. It is a harder language. There's more of a learning curve because you have to learn about references and pointers and so on. You have to make decisions about ownership of memory when you allocate memory, because there's no built-in garbage collector in C++. The plus side of all that is you get very fine control. You can choose where you make your trade-offs between speed and memory. That's something that's not so easy to do in other languages. But when you combine C++ with Qt, what you get is a very pleasant, easy-to-use API with the power of C++. And for example, Qt has a very good ownership model, which basically means you can pass the ownership of objects you construct on the heap with new to Qt, and Qt will take responsibility and it will clean them up at the right time, and you don't have to worry about that. So a huge amount of memory management burden that is in just standard C++ programs doesn't apply in Qt, because you can give the work to Qt. So in many respects, you get a combination of the slickness, if you like, of some of the aspects of Java, but with the power of C++. I think it gives a sense of comfort when we think about who else is using the tools and languages and libraries that we're interested in. And there are two huge families of users of Qt. There are the open source developers. The K-desktop environment is the standard windowing environment on Linux, used by tens of thousands of people around the world. And that entire environment is written in Qt, the fundamental windowing environment, let alone hundreds and hundreds of KDE applications written in Qt on top. So it's very widely used, and of course, that wide use means that it gets a lot of testing through practice and usage. But in addition to the open source world, there are a lot of commercial developers. And I think this is actually quite still a hidden aspect of Qt development, because although there are many applications that are widely known, like Skype, like Google Earth, which are visible to people as being Qt applications, there are a huge number of in-house applications that people use Qt to build. This, I think it's less than 20 lines, is a complete working GUI program. Okay? The program, you can see the window. I use a rather obscure window manager, which is why the decoration looks peculiar. If you click the button, if you press Alt-Q, or if you tab and press spacebar, the application will close correctly and clean up. And this is a model of how Qt applications work in microcosm. We create a Qt application object, which is a global-like object that gives you access to things like how big is the desktop this computer is running on, how big is the screen, and various other global-like information from the system you'd like to have access to. We then create a dialog, which gives us the main window itself, and we create a label and a button. And we lay them out using a V-box, a vertical box layout. Now notice there are no numbers. I'm not saying what position and what size these things are. And we'll get on to layouts later, because Qt has a very intelligent layout system that, in general, does the right thing. And when it doesn't, it's very easy to persuade it to do the right thing. So we create our buttons using new. So at the moment, we own that memory. We're responsible. We give them to the layout. And when we call set layout, Qt will not only lay out the form, but it will take ownership of all the things involved in that layout, both the layouts and the widgets. Widgets is the Unix term. Control is the Windows term for a visual component. So at that call, ownership is transferred from us to Qt. We don't have to worry. And you can write quite a few Qt programs where you never call delete, because you've always passed ownership onto Qt. The last line is interesting, we'll say a lot more about, but it's basically giving this application behavior. And it's saying when the button is clicked, say I accept, and accept in terms of a dialog means, OK, I'm finished with this dialog. It's the equivalent of pressing OK of an OK cancel. And we'll say more about that. But What I would mention now about it now is that we're not concerned with how that button is clicked. Do we care if they tabbed and pressed spacebar, if they pressed Alt-Q? Do we care if they clicked with the mouse? And if they did, where exactly on the button? 99.9% of the time, we don't care about those details. If you want them, Qt will give them to you, no problem. But what Qt has is a mechanism that we'll discuss shortly, which says, I'll throw away the irrelevant detail and just give you the stuff you want to know. And that's very useful. It leads to cleaner code. At the end, we give a title, and we say show. At the point we call show, all we're doing really is scheduling an event, saying show it when the event loop is running. The exec call kicks off the GUI event loop. And at that point, it says, have I any events? Yes, I've got to show myself. And then the application runs, and it just waits for the user to click the quit button, or even to click X at the top, and it will close, and we're done. Now, the code, I think, is very clean, and it's clear to see, and that is a complete application. I remember when I first started Win32 programming with C, it was 300 lines to get something like this up from, I don't know if any of you are old enough to remember the Pete Sold books, a long time ago. Okay, so that's an impression of what Qt looks like, although it does work. What I'm going to focus on in this talk, though, are the key components. Now, Qt4 has over 600 public classes, and they're broken down into libraries because, obviously, if you're not using certain types of functionality, you don't want to include that and bloat out your executables. And the areas that I'm going to focus on, I've listed there. I'm going to look at some of Qt's widgets, not all of them. I'll look at the signal and slot mechanism because that's key to Qt. It's an innovation that TROLLTECH came up with, and it gives us an event handling at a much higher level than being concerned with mouse clicks and particular key presses. It abstracts that to a high level, makes it very easy to program. Layout management. Now, we'll cover that. Basically, that's going to let us lay things out without having to do lots of tedious calculations. But Qt doesn't stop you from doing the tedious calculations if you want to. And that's part of the Qt philosophy. It gives you ease of use, it gives you power, but it does not stop you doing things the way you want if you want to do something different or special yourself. It doesn't prevent you or lock you in that respect. Qt Designer is a tool for graphically designing widgets and dialogues. And, of course, it's written in Qt. We'll talk a bit about graphics, text, and XML, input-output networking, because Qt brings a lot of things to these areas. And we'll talk about data handling, because Qt4 introduced a model view architecture, and it turns out that there are 3 talks on that subject in this conference, one given by me tomorrow, because it is very interesting and very powerful. And I'll give you an overview of what that is. And, of course, Qt is multi-threaded, so you can write threaded applications with no problem. I think this is really hideous, but it just shows you what you can do when you're given the freedom and perhaps not necessarily the design taste that one would wish to have. Styling Qt wasn't particularly easy prior to Qt 4.2, but now that you can use style sheets, it's incredibly easy, and we're going to see lots of really ugly applications out there as a result, I'm sure. But that's part of the freedom. Qt is not prescribing. It does not say, oh, you must develop a GUI application in the way we like. It just says, here's the tools. You use them. You take responsibility. OK, so styling you can do. It shows a few of the widgets. It's got buttons. It's got a line edit that you can set up as a password line edit. And you can actually have it so that whatever they type, nothing shows if you're really paranoid. Spin boxes for integers, for floating point values, date edits. And in Qt 4.2, the date edit, you can pop up a calendar, finally. It's taken them many years to do that. I wrote a calendar widget for Qt, and I put it in Qt Quarterly, which is the developers' newsletter, to encourage the developers, and they finally got around to doing it. I'm pleased about that. There are lots more widgets, but I just wanted to give you a flavor. And what it perhaps doesn't show is that there is a table widget, There's a tree widget and list widgets as well. So there's a lot of... it's not often that you're going to run out or find that you haven't got the widget you want. But it does happen. And then what are you going to do? Well, if you're using some toolkits, if it doesn't have the widget you want, you are really stuck. You've got a lot of work ahead of you. But that's not the case with Qt, and that's one of the things that's so wonderful about it. The easiest, there are 4 ways that you can get a custom widget in Qt, and the easiest is to take an existing one and just change some of its properties. So you just call set this and set that and change the properties that TROLLTECH think people are going to want to change. Another way is sometimes you have more than one widget that in combination give you the widget you actually want. A typical one is a file browser where you have a label and a button, and the button launches a file browser and the label shows the file or directory chosen. Now, Qt doesn't give you that, but you can produce that widget by taking a QLine edit, a QPush button, and using a QHbox layout to just lay them out together. You've got a new widget. It's that simple. But maybe that isn't enough. Maybe you want to customize. Well, you can subclass. You can subclass any Qt widget, and you can change its appearance, and you can change its behavior, either piecemeal or wholesale. It's up to you. If you've got a widget that is just like nothing else in the Qt library, or you want absolute control, you can have that as well, because you can inherit QWidget, and that allows you to paint your widget however you like. There are no constraints. You paint whatever you want. And every Qt widget is derived from QWidget, so you can actually look in the source code and see how the trolls have done it if you want to see like patterns of programming to use for that. In addition to controlling the appearance by re-implementing the paint event, you can also have total control of the behavior, because you can re-implement key press events, key mouse events, so that whatever interaction the user does with your widget, you can intercept and you can decide how you want to respond to that. And very often in GUI programming, the response is throw it away. It's only sometimes that you actually want to take notice. Like very often, if it's just a mouse move, you don't even want to know, because you're only interested in clicks, for example. So you've got 4 levels, basically, of customization and control, and the last level is the most powerful. And it is not hard. That's the other thing. If you compare it to certain other toolkits, where it can be a lot of lines to just get a bit of customization. Not so in Qt. It's actually quite straightforward to do. The signals and slots mechanism is now mainstream. If you look at Boost, it has a signals library as part of it, and various other toolkits have implemented kind of copies of the Qt signals and slot mechanism. But TROLLTECH were really the first to come up with this idea, and it's very powerful. And it's to do with throwing away the stuff you don't want to know. If a button is clicked, it announces, I have been clicked. So any widget in Qt will announce state changes. So a button will say, I've been clicked. A checkbox will say, my state has changed. I'm now clicked or unclicked or in between if it's a 3-way checkbox. A list widget will say, this item has been clicked or selected, or this set of items has been selected. So every state change is announced by the widget. And it's just announced to Qt. I've been clicked. This has been selected. And all of those announcements you can ignore. You don't have to take any notice of them at all. But if you're interested in an announcement, you can connect to it, and we'll see what that means in a minute. So you can say, OK, I want to know when that button's clicked because I want to do something in response. Or when that menu option is chosen, I want to respond to it. I want to deal with it. So you can connect to it. But the connecting does not mean that the component that announces the state change knows anything about the connection. So you don't get tight coupling. You've got lots of flexibility. So this leads us to being able to treat our widgets as independent components. They announce state changes. They may respond to signals going into them, but they're independent of each other. And we as programmers can say, OK, they're connecting up in this particular hierarchy or in this particular way. but that is independent of the components themselves. The other thing about the signals and slots mechanism is that you can pass parameters. So, for example, in a combo box, if the user types in or selects some texts, it will announce that its text has changed, and it will carry a Q string with that actual text. And it's type safe, so you're not going to get the crashes that you've had with perhaps older toolkits, which basically pass void pointers to functions and things like that. There is type checking, so if you get a type mismatch, you will not get a compiled program. You'll get an error. Okay. So here's a very simple example. These are two standard Qt components, a spin box and a slider. They don't look very pretty, like expanded and stretched by the display, but they do look pretty in a real application. And I've connected the spin box's value changed signal. And basically, whenever the numerical value in that spin box is changed, whether the user clicks the little arrows or types in a new number, this thing will say, I've been changed, here's my new number, 55, 99, 7, whatever that number is. And it doesn't know if or to whom it is connected. But I've connected it to the slider, which has a set value slot. Now, a slot is actually just an ordinary member function, but it's when you're writing your class, instead of just writing private and then the name of this function, you write private slot. And that's all. And Qt will take care of turning that into standard C++ for you. So that one announces a change. It goes into this one set value. So this one moves to the 67 position in this particular case. Similarly, I've connected the other way. Now, you might wonder, well, isn't there going to be an infinite loop? But in general, most slots begin with code that effectively says, if the value coming in is the same as the one I've got, return. And they only do anything if the value is different. Now, I think it's a very simple and clear mechanism, and it focuses on the high-level things that we're interested in, rather than the low-level detail of where a particular click took place or the state of the shift key and the control key when they press the mouse. However, all of that low-level detail is still available to you in Qt. It's just that we ignore it most of the time because most of the time we don't care. You can create your own signals and slots just as easily. So, for example, if you wanted more functionality, you could subclass a QtWidget, and you could add additional signals, additional slots to give it additional behavior that you wanted. I'm going to move on now to another technology. Now, I think most of us who have seen Java, I suppose, was the first mainstream language that introduced layouts in a significant way, although the TK toolkit had introduced them earlier. Qt has a layout system. The picture on your left shows some of the layout. Okay. Basically, on the far left, we have a vertical layout of two items, a label and a list widget. On the right, inside the group box, we've got a vertical layout. And then we've got another vertical layout of three items, the group box, the spring, the blue spring, which is called a stretch or a spacer, and time edit. Okay, so they're laid out vertically. And then those two layouts, side by side, are themselves put in a splitter. So the user could use the splitter to drag and resize themselves if they wanted to. There's another layout on the bottom, and then the two groups are again laid out in a vertical layout. So you can nest layouts as much as you like. Now what benefits do you get from using layouts? Okay, firstly, no hard-coded numbers. You're not saying, I want this widget at this position of this width and height. You can if you want to. There's nothing to stop you doing that. But very often you don't want to do it. Time after time when I'm using Windows applications, I get little dialogues with lots of content, and I want to make the thing bigger, and it won't resize. Now, by default, QtWidgets will resize. You can say, no, they're fixed size if you want, because Qt lets you do whatever you choose as a programmer. But by default, they're resizable. And if you were to resize this, it would behave in a sensible way. this gap would grow, and of the label and the list would stay the same height, the list would grow longer and longer, because Qt not only has layouts, it has preferred layout behaviors. So a list prefers to grow. If it's given the opportunity to grow, it will grow. Whereas a label prefers to grow horizontally. It does not want to grow vertically beyond what it actually needs. Buttons, again, they'll grow horizontally, but not usually vertically. Now, those are layout policies, and every Qt widget has default layout policies that are sensible. But you can just say, I want to change the layout policy from this to whichever one you prefer, because there may be cases where you want a different layout. So you can use, I've only used vertical and horizontal layouts, but there's also grid layouts. And one of the things about grid layouts is they support spanning rows and columns. All the layouts are nestable. So if you nest horizontal within vertical, within grid, use splitters, use tab widgets, it's very hard to imagine a layout that you could not get with Qt. And I've certainly never hit a wall where I found, oh no, I can't do this layout, however complicated. And I think we all know if we do like configuration dialogues, which are often multi-tab and very complicated, or at least the ones I've worked on are, I never hit that limit. I sometimes have to have a good think about how I'm going to do it and play in Qt Designer to get a feel for how to approach it. But every layout you want, you can achieve. And that brings us on to Qt Designer. Now, I think programmers tend to be in two broad camps. Those who like GUI tools, they like integrated environments, they like design tools, and those of us like myself who are, I suppose, more old-fashioned, we just like command line. Now, if you like programming just in text and you don't like all this stuff, that's fine with Qt. Okay? I do all my layouts, all of my design, just by using the classes. I create a QVBox layout, a QHbox layout, and so on. And I just type in the code and get the layouts I want. Okay? And Qt's layout system was designed to be hand-coded, so it works in a sensible way for someone who's writing that code by hand. Qt Designer came along later and was provided as an easy way for developers who didn't want to spend that time in that particular way to visualize designs and produce designs. And it fully supports the layout system. So you can set the layout policies, you can do signal slot connections, and you can use any of the layouts that you like. And what it does is it saves the layout just as an XML file, and part of Qt's build process will turn that XML file into C++. Okay, so at every stage you end up with C++, and you can look at it if that's what you want to do. Okay, so it is a nice tool. I've got it shown in. It has two different display modes. This is multiple document interface mode, where it's just one window. There's another mode where it's like windows all over the place, if you prefer that. Okay, and of course this was written in Qt. And the way that you use the forms is that you can. There are three different methods that TROLLTECH gives in the documentation. You can aggregate or inherit. I tend to use inheritance. And one of the nice things about Qt Designer is, if the only thing you change is the layout, you don't change the source code that makes use of it. You don't have to. Okay? The only time you're going to need to change your source code is if you want a behavior change, or if you've added or taken away particular widgets that you'd had in your design. So it's actually a different form. The other thing that you can do with these .ui files, XML files that Designer produces, you can actually load them dynamically at runtime in a program and have a form constructed. And you can use Qt's introspection mechanism to find out what the widgets are and to change their behavior, set their values, get values from them. And some customers find that very useful. Okay, doing fine. Graphics is something that Qt has always been good at, but I think with Qt 4.2, it has gone huge steps forward. And suppose we divide it into two camps. There is the kind of bitmap graphics that you're seeing there. This is one of the demonstration applications that is provided with Qt, and there are several others in the same style that show you different aspects of the graphics system. It has a 2D paint engine that's very flexible, very powerful. It fully supports anti-aliasing, both for lines and text. It'll draw all the standard shapes that you want. I don't know why some of the words have grown large. The person who received this, the presentation from me has obviously changed some things in it, or perhaps they like curves, images, and text. But you can also create painter paths, which are basically combinations of the primitives, rather in a similar way to the way you can in PostScript, where you collect things together and then you paint a path of a complex shape. There are lots. Well, in terms of pens and brushes, you can set custom ones, of course, but there are also, you can use fills, both solid, patterned, and gradient fills, and the gradients are both, you've got the choice linear, radial, or conical. So a huge variety of choice with pens and brushes, if you like that. But the other thing that is very nice about the Paint engine is it's, again, a uniform API. So if you're creating a widget, you can paint on that widget, fine. If you want to print that widget, you can paint using the same code on a QPaint device. And similarly, you could pass in a QImage or a QPXml, and you can paint onto that as well using the same code. So often I have a paint function which just calls my custom function with the QPaint device I'm actually going to paint on. And that gives me the choice of whatever type of painting I want to do. So it's a powerful engine. One thing I don't cover here is the new QGraphics View class that was introduced with Qt 4.2. And that's a vector-based paint engine. So obviously it's very fast, and it gives you superb scalability. But having said that, this scales pretty nicely because of the anti-aliasing. For people who are interested in OpenGL, there is a QGL widget, and there are various other OpenGL-related classes. So you can basically put an OpenGL region into a Qt application, or more than one region if you wish, and you can use it either for 2D or 3D, because OpenGL is 2D as well as 3D. And you can do the mouse handling and the key handling at the Qt level. And I think most programmers find it easier to do the event handling at the Qt level rather than in OpenGL. Okay. Text is obviously not as glamorous as graphics, and yet it's very fundamental to programming. Now, Qt has used Unicode for many years. So it really doesn't matter to Qt whether it's Arabic, Chinese, Hebrew, or Latin scripts. If the fonts are in the machine, it can display them. And it also has some pretty clever code for when the fonts are incomplete. So, for example, you might have a particular font that's missing some Greek letters. Well, if Qt can find those Greek letters in another font, it will substitute as best it can. The other thing is Qt has a notion of rich text. Now, if you've come from the Windows world, you might be familiar with rich text format. Qt rich text is totally different, okay? It's basically HTML 3.2 and a bit of 4.0. So it's very easy to type in and use directly. So there's just a tiny bit of HTML. You could put that on a Q label, and it will show up as you would expect. Qt provides a QtXedit widget, which is a multi-line text editor. It can work in paragraph mode. It can cope with HTML formatting and things like this. Or you can switch it and say, I want you to just be plain text. So the ability to work with text is very strong in Qt. And I suppose that leads us towards XML. Qt provides two different APIs because there are two popular APIs out there which are very different. Sax is an API which is typically used for very large XML files or where you're quite happy to read things in sequence. And Qt's API is based on the Java Sax2 API because that's a very popular API. And it's actually slightly unusual for Qt because it's modeling a non-Qt API. It has a slightly different feel, but it's not hard to use at all. And if you're used to the Java one, you'll be right at home. There's also a DOM API based on the W3C's DOM reference. And that's also, I think, pretty easy to use. And, of course, saving with DOM is a one-liner because you just read the thing in, one lump, you've got it, and you can say to Qt, just put the whole thing in a file for me. But it's not terribly hard to write your XML if you want to do it manually as well. And we've moved from text to XML to sort of more general input-output. Now, natively, Qt uses Unicode. It can work with UTF-8, UTF-16, and most local 8-bit encodings. Now, in Europe, we don't have that many encodings, well, especially in Western Europe. But Qt can deal with a lot of encodings, including Asian encodings, as well as Unicode. Qt has QtXml, which is concerned with writing quotes plain text. Of course, there's no such thing as plain text. You have to nowadays be sensible to which codec you're using. But with Qt, you can create a text stream and you can say, I want to use this codec, UTF-8, Latin 1, whatever the one you want. And then you just write plain text as normal. And when you're reading back, you choose the codec you want to read in. But Qt also provides a class called QDataStream. And QDataStream is, I'm a great fan of this particular class because it allows you not only to store basic plain old data types, like ints and doubles and so on, but many of the Qt types, including some of the Qt containers, like QList, for example. I haven't mentioned on there, but QMap. So you can actually store quite complex containers, even recursive containers of maps, of lists, of vectors, and so on, with Qt, with no problem. And because QDataStream uses a platform-independent binary format, you could be on a 64-bit big-endian machine and read and write that data just as easily on a 32-bit little-endian machine with a totally different operating system. And it will work perfectly well. So it doesn't matter what platform you create your binary files on, if that's how you store your data. It can be read on any Qt platform you deploy at. And if you've tried to do that manually in C++, that isn't trivial to do because I have tried it. So QDataStream is a pretty impressive class in my view, and it's also incredibly fast because, of course, when you're reading back, you don't have to parse. You just say, I'm expecting a QDate or a this or a that, and you just read it straight in. Qt has strong support for networking. It doesn't have a built-in client-server architecture, but it does have all the tools you need to build client-server applications, both servers and clients. Supports TCP and UDP as you would expect. Can look up host names, and it can work with HTTP. It can do HTTP requests. But the classes, the class hierarchy that's provided for networking is, of course, quite open and accessible to you. So you can subclass it to support your own protocols. Model view architecture is something new and that was introduced with Qt4. For those of you who are not familiar, this is an idea that comes from the world of Smalltalk. And basically, it's about separating your data from the presentation and editing of that data. And some of the strengths of this are as follows. You have this model, which is a software component that mediates between the data and the rest of your application. Now, that means if you change the form your data's in, maybe you were using binary files, you've now switched to a database. The only component that needs to change is the model. Everything else talks to the model, and the model's API is uniform, unchanged. So you get the flexibility to change your underlying data. That's one benefit. Another benefit of model view is that the model only retrieves and writes back the data it actually needs. So if you've got millions of records, the model is not going to ask you for millions of records because that's not going to fit on your screen. It will ask for what is actually displayable and what is actually requested. Now, the model talks to, I've shown one view, but in fact, there are no limits to how many views you can have connected to a particular model. And I think most of us have at some point or other used Excel, and we've done window splits, so we could see two different parts of a spreadsheet, for example. Well, using this architecture, that's trivial to do. You just create two views on the same data set, and the user can navigate to different parts. Or 3 views or 4, there's no limit. Now, the view manages, in a sense, the big picture. It takes care of generally the rectangular area where items of data are displayed. The delegate, in Smalltalk language, we'd say it was the controller, but in Qt we use the word delegate because it's a bit different and more powerful than the Smalltalk controller. The view says, I need to display this particular item. And it says to the delegate, you go display the item for me. Here's the little rectangular area that you've got to display it in. And then the delegate will talk to the model and say, the view's given me the index of the thing to display. Give me the data to display, I will display it. Now, every view that comes with Qt has a built-in delegate. So you don't have to create one at all yourself. It just happens. It just works. But in my talk tomorrow, I go into delegates much more deeply and show that you can do some pretty impressive things with them because they allow you to control not just the presentation of data, but how it's edited. Okay? Well, if you're interested, you can ask questions. But here's an example of a table. And the first column is read-only. The second column is plain text. The third column is rich text. So it's HTML formatted. It's got superscripts. It's got colors. It's got different fonts. The category column, if you initiated editing on that by double-clicking or pressing F2, or however you've designated as the means for initiating editing, it'll turn into a combo box with a fixed list of values. And the other two give you spin boxes, one for integers, one for floating point values, with specified ranges. All of that's possible and actually very easy with the model view architecture. So you can get not only, I think, quite impressive looks, but very fine control over the editing. Okay. Now, we're doing fine. So far, we've talked about the visuals, and we did touch on text and file handling and the model view architecture. But at the very bottom, if you like, of data handling are the basic containers you use, the vectors, the maps, and other kinds of containers like that. Now, if you're used to C++ and you're used to the standard template library, you know about list, vector, map, and the other classes in those libraries. All of those can be used with Qt as is with no problems. So if you like the STL and you're happy with it, you can use it without doing anything special. But Qt offers its own set of containers. Not as many, but they work in a Qt way. They're very pleasant to program with, and you'll find in the documentation that their performance is listed. So you can see their time complexity and their growth strategy. So you can look at the container and say, okay, this is the performance I want. What container is going to work for me? What's going to deliver the performance I need? And in addition, Qt provides some algorithms, but again, you can use the algorithms from the standard template library, not just with the STL, with Qt's containers. And you can iterate using STL-style iterators. But if you've not used to the STL, that kind of stuff can be quite intimidating. So what Qt also offers are Java-style iterators, which work like the Java ones, have similar naming, and I think are genuinely easier to use. But the easiest of all is the for each loop. With that, you can say for each item, comma, container. And that will give you a read-only iteration over every element in a particular container. And that's awfully convenient and easy to write. The other thing to bear in mind about Qt, not just about things like QString or QtXml, for storing strings and images, but also all of the containers like QMap, like QList, like QVector, is they use copy on write. So passing by value is very cheap in Qt. Now, of course, as a matter of good practice, we generally pass anything other than an integral type or a double by constref. And there's no reason not to do that in Qt, and in the Qt API, that's done extensively. But you don't have to, and you won't pay a price if you pass by value. Unless, of course, you change the thing that you've passed, and then you pay whatever the copy price is. But there's no avoiding that, whatever the toolkit. Okay. With threading, well, in Qt4, prior to Qt4, Qt came in threaded and non-threaded versions. With Qt4, the library's threaded. And the reason that TROLLTECH were able to make that change was because they nailed down the efficiency problems they'd had earlier with multi-threading. And basically, you were not getting a performance penalty for having Qt multi-threaded anymore. The very low-level atomic operations in Qt are implemented in assembly language, not in C++, in assembler for the different platforms and architectures to maximize speed of threading. But certainly the GUI toolkits I've used, you're only allowed one GUI thread, but you can have as many non-GUI threads as you like. And Qt offers two mechanisms for communication between the non-GUI threads and the GUI thread. One is the signals and slots mechanism, which is obviously the easiest and smoothest to use. But you can also use QEvents. And I think it's probably worth just mentioning, Qt has two levels of event handling. High-level event handling is signals and slots. And that's just concerned with the big picture. Something's been clicked, something's been selected, state changes in widgets. But Qt also has a low-level event handling system, just like all the other toolkits, which actually tells you the details of what the state of the mouse buttons, the keyboard, where the click took place, and things like that. And you can, if you want to change behavior at a deep level, you can re-implement the event handlers so that you can get complete control over what happens when the user does particular things with the mouse and keyboard. And that mechanism is also used, and because it's a general mechanism, it's not just limited to keyboard and mouse events. You can use the event system to create your own events. You can create your own event subclasses, which you can use in addition to the Qt ones. And Qt actually, I can't remember how many Qt events there are, but there are a lot of events that you can make use of and intercept. Now, I've probably talked too quickly because I got through more than I expected by now. So I'll actually spend a bit of time on some of the things I haven't had time for. Qt has a very powerful plugin system, and there's two kinds of plugins that you can use with Qt. There are plugins into Qt itself, which means you can add some functionality to Qt that's available to every application you develop. But Qt also gives you a plugin mechanism that you can use in your own applications. And like everything else in Qt, it's cross-platform. So you can have a plugin system that will work on Windows and on Linux for your application. You still have to provide, like on Windows, you'd provide a DLL, and on Linux, you'd provide an SO, but the code in your application executable would be the same because the suffix Qt will figure out depending on the platform it's running on. So it will grab in the functionality that is available to it. And I suppose the chief benefit of that is that if you build in a plugin system, you can ship additional functionality after the whole application is shipped, which can help stretch deadlines a bit. Although mostly I've spoken about Qt in terms of cross-platform, there are some technologies on particular platforms that are either very popular or very compelling, and Qt doesn't ignore those. So, for example, on Windows, Qt has the Active Qt module, which provides ActiveX support. So you can do all the things with ActiveX you want to do, but obviously they're Windows specific. Similarly, now I'm not a Mac user, so I don't honestly know what sheets and drawers are, but Mac people I'm sure do, and you can have those in Qt. And obviously there are also some things that are Unix specific. One that Matthias mentioned this morning was dbus, for example. Now Qt also provides QtTestLib, which is for unit testing. And it's very simple and easy to use, and it uses C++. So if you and your team are developing in C++ and you want to test your code, you can just write more C++ to do your testing. It does not provide like comparisons of, for example, screens. So you can't compare this widget with that widget in terms of their state. But you can query widgets. So you can, for example, test GUI components by creating the component, calling methods on it, and then to set things, and then calling other methods to see if the results that, in terms of its internal state, is what you expect. In addition, though, there are third parties who offer testing tools. I mean, the one that I've used is Squish from the TROLLTECH guys, which is a GUI testing tool. Vector drawing and SVG support. Qt right now can load and save SVG. Scalable vector graphics. It's an XML format to represent vectors rather than like pixmaps. I've seen it used quite a bit in on web pages, but I haven't seen it used much else myself. But it's very popular because, of course, it's scalable. So you don't lose resolution no matter how big or small you make things. And more support for SVG is coming. Printing, fine with Qt. I can't remember if it was 4.0 or 4.1, but you can print PDF direct. You don't have to go through some third-party application or through hoops to print PDF. You can just say to Qt, I want you to print in PDF format, please, and off it will go and do so. Now, one thing I didn't mention, and yet is a very big deal, is databases. And in a sense, I didn't have to, because the databases with Qt is fully integrated with the model view. So as far as Qt's concerned, a database is just another source. And if you remember, we had data source, model, and view. You just substitute in whatever your previous data source was, say a file, with a database connection, and it'll work just the same way, because the model has the same API to your application. So it doesn't matter what that underlying data source is. And Qt comes with drivers for all the popular databases, DB2, Oracle, MySQL, and so on. The other thing that I mentioned at the beginning was that Qt is not only an application development framework, it also comes with a set of tools. QtLinguist, which Matthias seems to have mixed feelings about, is still, I think, a very nice tool, and it's to support translators. In Qt, what you can do is when you have a string that you know is going to be user visible, for example, the label on a button or just an ordinary label, instead of putting it in double quotes, you can write tr, open parenthesis, double quote, string, and then close the parenthesis, the quotes in the parentheses. And tr stands for translate. And what happens if you just run the application with all these TRs is nothing. It just runs normally, and there's no surprises or excitement. However, these TRs mark all those strings, and Qt comes with tools which will read the source code, and for every string that's so marked, will produce a file which QtLinguist can read. So you'll get a list of all of the strings that you've used in your application. Furthermore, it's a bit smarter than that because it knows which class those strings are in. So you instead of just getting OK and not knowing where that is, it'll give you OK and it'll give you the dialog that's in, or find, or whatever the string is. And then a translator can come along and use QtLinguist. A QtLinguist is a GUI tool written in Qt, of course, that's actually very user-friendly and easy to use. So a translator can come along and they can translate into whatever your target language is. And it has nice features like if they've translated one word or phrase and that phrase appears again, it will suggest their previous translation, so they don't have to do the same one over and over. And it's got lots of nice touches like that. Qt Assistant is a help tool. And basically, it's used by Qt. If you're a Windows user, you probably use Qt Assistant. But you can use it for your own help files as well. I'm conscious of time. Yeah. QMake is something that you would face if you're more likely if you're a Unix developer. On Windows, you're probably going to use Visual Studio and the integration, and you're not going to really know or care about how it compiles. It'll compile and it'll do the right thing. But if you're on Unix, you may well use QMake. And this is a command line tool, and it produces makefiles. That's it. But it's very smart about the makefiles it creates because it understands all the things that Qt needs. So, for example, it will create makefiles that will automatically recognize forms that have been created with Qt Designer and turn them into C++ and integrate them into the build. And you can use it on Windows, and I personally do use it on all platforms because I find it easy to use and understand. Okay, now those are the formal things that I wanted to say. There is more and more and more, of course, to Qt. I wanted to give you the technologies that I think are key and that are most widely used. But there are so many more. There's so many more widgets, and there are other technologies in Qt. So I think I'd like to put it open to you if you've got questions about anything that we've covered, anything that you think is missing that probably isn't, or any other questions relating. Yes.